Hello everyone, welcome to the solution of LeetCode problem 67 named add binary. In this problem, we are given two binary strings A and B and we have to return their sum as a binary string. Now let's analyze the first input. Here the value of A is 1 1 and the value of B is 1, so the binary addition is 1 0 0. In the example 2, the binary string of A is 1 0 1 0 and the binary string of B is 1 0 1 1 and the output is 1 0 1 0 1. I hope you understood the problem. Now let's explain the constraint. Here, the length of both of the string can be in between 1 to 10 to the power 4 and both of the string will only contains the value 0 or 1 and it is ensured that both of the string must not contain any leading zeros. I hope you understood the problem and constraint. Now let's move on to the solution. As this is the typical binary addition problem, we have to understand the binary addition rule. The binary addition rules are: if both of the value is 0, the result will be 0. If the first value is 0 and the second value is 1, the result will be 1. If the first value is 1 and the result will be 0, the result will be 1. And if both of the value are 1, then the result will be 0, but the carry will be 1. Anyways, I hope you understood the rule. Now let's see how can you solve this problem by using this rule. At first, let's consider one different example. The binary value of first string is 101101 and the binary value of second string is 1001 and 01 and this is the index number. Anyways, we are using some variables to solve this problem. At first, we are using I and j. The value of I will indicate the index value in the first string. The value of j will indicate the index value in the second string. Now at first, both of our I and j is indicating towards the last position of the string. So the value of I is 5 and the value of j is 5. Now, if we add 1 and 1, the sum value will be 2 and we have to find the carry. If we want to find the carry, we have to divide the value of sum by 2. Now, our carry is 2 by 2, which is 1. And we have to append the value of sum percent 2 into the result. So in this case, the sum is 2 and 2% 2 is equal to 0 because by applying modular operation in both of the 2's, the result will be 0. So for the first iteration, we have found our result 0, but our carry is 1. Now our current I and j is indicating this position and the value of 0 plus 0 is 0. Previously we had 1 carry, so we have to also include it. So the value of 0 plus 0 plus 1 is 1. So we have to put 1 here. Sorry, in the previous iteration, we forgot to put 0 here. Now our carry will become 0 and current result will hold the value of 1. Now our current pointer is indicating this third element from the back. Similarly, 1 plus 1 is 2. So here the value of sum is 2 and for the carry we have to divide sum by 2. So here if we divide 2 by 2, the carry will be 1. And for the result, we have to apply the modular operation. So if we apply 2 modulus 2, the result will become 0. So we have to put 0 here. Now our current pointer is indicating this element, which is 2. Here the summation of 1 and 0 is 1, but we have 1 carry. So the summation of 1, 0 and 1 is 2. So for the carry, we have to divide 2 by 2. So our carry will become 1. And for the result, we have to apply the modular operation between these 2's. So the 2% 2 will become 0. So we have to put 0 here. Now our current pointer is pointing this element. The summation of 0 and 0 is 0, but we have 1 carry. So here the summation is 1 plus 0 plus 1, which is 1. Because for the result, if we apply modular operation between 1 and 2, the result will be 1. And for the carry, if we apply the divide operation between 1 and 2, which is 1 divided by 2, the carry will be 0. Now, our current pointer is indicating this last element. Here, both of the value A and B is 1, but our carry is 0. So here the sum is 1 plus 1 plus 0, which is 2. So for the carry, we have to divide 2 by 2. So if we divide 2 by 2, the carry will be 1. And for the result, we have to apply the modular operation between 2 and 2. So the modular operation between 2 and 2 is 0. So we have to append 0 here. But now our I and j will become out of bound. But wait, we have a carry here. So the algorithm must be continue. So for this situation, the summation value is 1, which is carry. And for the last bit, for the result, we have to apply the modular operation between 1 and 2. So if we apply modular operation between 1 and 2, the result will be 1. So we have to append the result 1 here and here as well. And finally, the iteration is over. Now our result string will something look like this. If we apply the reverse operation here, the result string will become the actual result. Because if we apply the reverse operation here, the resultant sequence will become 1010010. So by applying this algorithm, we can add two binary strings. I hope you understood the algorithm. Now let's move on to the code. In this code, we are given a function add binary. The parameter of this function is two binary string a and b, and the return type of this function is also a string. Now at first, we have to take empty string for storing the result, and both of the I and j will point to the last element, and the initial value of our carry is 0. And we have to perform a while loop. We have to check either our current I is greater than or equal to 0, or either current j is greater than equal to 0, or either our carry has some values. If any of the conditions true, then we have to insert the carry value into the sum. And if our current I is greater than equal to 0, or we can say that our current I is inbound, then we can simply add our current I value with the sum and decrement the I pointer. And similarly, if our current j is inbound, we have to add the current j value of the second string with the sum and decrement our j. And finally, for the carry, we have to perform the divide operation between sum and 2. And for the result, we have to perform the modular operation between sum and 2. And finally, we have to reverse our string. And at last, we have to return the result. I hope you understood the code. Now let's move on to the time and space complexity of this program. In this program, the time complexity is big O of n, where n is the length of the larger string. And the space complexity is also big O of n, where n is the length of the larger string. Because in the worst case, the size of the resultant string can be equal to the size of the greater input string. I hope you understood the time and space complexity of this program. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.